Across the vast universe, astronomers have discovered planets orbiting not one, but two stars at the same time. These strange worlds exist inside binary star systems, where two suns circle each other in space. One of the most famous examples is a distant world known as Kepler 1/6b. Unlike Earth, this planet does not orbit a single star. Instead, it travels around the combined gravity of two stars moving in a cosmic dance. As the stars orbit each other, their light constantly changes across the planet. This type of world is known as a circumbinary planet. From space, the system looks like a complex gravitational ballet. The planet must carefully follow a stable path around both stars. If the orbit were slightly different, the planet could be thrown out of the system. On the surface of such a world, the sky would look truly extraordinary. Two suns could rise and set at different times. Sometimes both stars would shine together in the sky. At other moments, one sun might eclipse the other. The result would be constantly shifting light and shadows. Landscapes would be illuminated by the combined glow of two stars. Nights might arrive later than expected when two suns linger in the sky. For astronomers, discovering these systems changed how we understand planetary formation. It revealed that planets can survive even in the complex gravity of two stars. And somewhere in the galaxy, there are worlds where two suns rise over an alien horizon. In a binary star system, two stars orbit each other in a powerful gravitational dance. Around them, a distant planet can follow a much larger orbit that surrounds both stars. These rare worlds are known as circumbinary planets. One of the most famous examples discovered by astronomers is Kepler 1/6b. From the surface of such a planet, the sky would look unlike anything on Earth. Two suns could rise above the horizon, casting overlapping light across the landscape. Because the stars move around each other, their positions in the sky constantly change. Sometimes the two suns would appear close together. At other times, they might be separated far across the sky. This movement creates complex cycles of daylight and shadow. Landscapes could be illuminated by two different directions of sunlight. Mountains and valleys might cast double shadows across the terrain. The brightness of the sky would shift as the stars move through their orbits. Occasionally, one star might partially eclipse the other. During these moments, the planet would experience strange and beautiful lighting. The combined gravity of two stars also shapes the planet's orbit. If the orbit is too close, gravitational forces could destabilize the planet. But at the right distance, a stable circumbinary orbit can last for billions of years. These discoveries show that planets can survive even in complex stellar systems. And somewhere in the galaxy, there are worlds where two suns share the same sky. Imagine standing on the surface of a planet where two suns shine in the sky at the same time. The landscape would be illuminated by light coming from two different directions. As a result, objects on the ground could cast two distinct shadows. These shadows would slowly move as the stars shift in the sky. Mountains, valleys, and oceans would glow under the combined light of two suns. The brightness of the day would change constantly as the stars orbit each other. Sometimes both stars would appear high in the sky together. At other moments, one sun might begin to set while the other continues to shine. This creates a strange and beautiful cycle of light across the planet. Twilight could occur while one star is still visible above the horizon. Clouds in the atmosphere would reflect the light of two stars at once. The sky might glow with unusual colors as the light mixes together. During rare moments, one star might pass in front of the other. These stellar eclipses would create dramatic changes in brightness. The planet would experience constantly shifting patterns of daylight. Over time, these cycles would shape the climate of the entire world. Winds, weather, and temperatures would respond to the movement of both suns. Scientists study these systems to understand how such planets evolve. Each discovery reveals new possibilities for how planetary systems can form. And on a world with two suns, every sunrise would be unlike anything seen on Earth. Beyond the strange skies of two suns, the physics of these systems is even more fascinating. In a binary star system, both stars orbit a shared center of gravity. A circumbinary planet must orbit far enough away to remain stable. If the planet were too close, the gravity of the two stars could tear its orbit apart. But at the right distance, a planet can travel safely around both stars. These stable paths can last for billions of years. Computer simulations help scientists understand how these orbits remain balanced. The movement of the stars constantly shifts the gravitational forces in the system, yet the planet continues its steady journey around both suns. From space, the system appears like a slow cosmic dance. The two stars circle each other, while the planet circles them both. This rare structure challenges earlier ideas about how planets form. Astronomers once believed such systems might be too chaotic for planets. But discoveries like Kepler 1.6b proved that stable circumbinary worlds can exist. Each new discovery reveals that the universe is far more diverse than we imagined. There may be countless planets orbiting two suns across the galaxy. Some could even have climates shaped by the light of twin stars. These worlds remind us that planetary systems can form in many different ways. Every discovery expands our understanding of how planets survive in complex star systems. And somewhere in the universe, a distant world may still be orbiting peacefully beneath two rising suns.